Okay, so if you can write that down in your notebook. Next lesson, the vector triangle. Okay, got that? Yep. Alright, so you can add vectors together by using what we call a vector triangle. So let's take two vectors, vector A and vector B. And we want to know what is vector A plus vector B, which we call the resultant. So just so I can draw that. Maybe, for example, this is vector A, and maybe, for example, this is vector B. And we would like to know what is A plus B. We want to know what that is, okay? We call the answer, this answer is called the resultant vector. And you know this word resultant, it's like this word, result. What does this mean in English? What's the meaning of this word, result?
Just result, what you get.
Yeah, what you get, the answer, yeah? So we call this the resultant vector. I think you should write this down. So vector A plus vector B equals resultant vector if you have vector A plus B. Okay, so you need that vocabulary, resultant vector. You could say the resultant vector is the vector you get when you add two vectors. You know, something, write something like this. Okay. Now, you don't have to, but you know, you could call it or, but I mean, you could call it C. It doesn't matter. You can find this vector by using this picture. It's called the vector triangle. So what you do, let me explain. Say you have vector A, there's A, and say you have vector B, there's B, and you want to add them together. What you do is you move B's tail to be at the head of A. So carefully you take this and move it down, keep the length and the direction the same. So if this is 45, this is still 45, for example. And then what you do, when the head of A is at the tail of B, you just draw one vector from here, the tail of A, to the head of B. And this is the result. So this is called the vector triangle. It's simple. You take one vector and put its tail at the other one's head. Now you might wonder, do you get the same answer if you do it the other way? If you put this tail at this head? Do you think that's the same or different? What do you think?
Which?
If you put this tail at this head, it's the same.
Yeah.
It makes the same vector as or here, doesn't it? Okay. So if you can draw this, it's called the vector triangle. Okay. If you can make a copy in your notebook, please. Yeah. my Chinese students always make such tiny little pictures. It's from, you learn this in school in China, yeah? Use a little bit of paper, yeah? It's like 2 centimeters. Okay. Now, you can multiply a vector by a scalar. So, for example, maybe you know this. You can tell me. Let's say this is vector A, and I want to take vector A, and I want to multiply it by a number. Let's say I want to multiply it by 2 to make 2A. How does this change? What happens to this? Does any of you know? Yeah, exactly how much longer?
2 times.
2 times longer, yeah. So this is 2A. What would you say this one is?
Half.
That would be a half A. And what would this be? If this is A, that's me. If this is A, what's the other one? Let's see what it says.
It's the same scalar.
Yeah, well, I think he has it. This is minus A. So if this is vector A, then this is vector minus A. That's all that happens when you put a minus in. Yeah? Okay. So if you multiply a vector by a scalar, such as 2, then it will double in length. Likewise, if you multiply it by a half, it's half the length. And if you multiply by minus 1, it would change the direction 180 degrees. So what I want you to do, I think it would be good if you could maybe draw some examples in your notebook. So let's say that's, I'll be more Chinese, I'll make them smaller. That's what I'll do. So I'll say that's A, that's 2A, this one here, minus A, and then this one here, a half A. Yeah? Okay, so can you copy those examples in your notebook? That'd be useful. Okay, got that? Yep, right. Now, we can plus, minus, multiply, divide scalars. You learned that you learned how to do that in baby school. We can multiply or divide a vector by a scalar. That's what we did here. We multiplied by 2 and divided by 2. Okay. We can add vectors. How do we add vectors? We use the vector triangle. And in fact, we can subtract vectors as well, because if I say A minus B, that's just equal to A plus minus B. So you can actually subtract vectors as well. But what we can't do, we cannot multiply 2 vectors. Yet. Not in this course. In university, you'll learn how to multiply vectors, but we don't do this, multiply vectors. Okay? You might do this, you do engineering, so you'll do this in maths class actually, in the 2nd semester. You'll learn how to multiply 2 vectors. And you can never, ever, ever divide vectors. Never. You never learn how to do that. So you cannot do vector A divide vector B. Okay, it's not possible. So let's see. Let's look at this one. I think before I do it, I think I want you to try it first, because I think you can do it. I believe in you. So I will do this one in 2 minutes, but I want to see if you can do it. So the first thing I want to do is to draw these vectors. Vector A is 5 kilometers east, and vector B is 5 kilometers per hour north. First, draw the two vectors. Let me see you draw them. Yeah, and let's see, B.
Okay.
5 kilometers per hour north. Hmm? Mhm. Good. Can I see yours? Can you show me, Joe? I can't quite see. Good. Okay. No problem. Right. B. Can these vectors be added? What do you think? Can you add these vectors?
No.
Why not?
The unit's different.
Very good. I tried to trick you. I tried to trick you to think that you could add them, but you can't, because A is in kilometers and B is in kilometers per hour. So you actually are not allowed to add them. Yeah? Okay, good. So the answer is no, because different units. Okay, so we can write that down. No, because different units. What's wrong, Ben? It was your idea.
Okay.
You changed your mind? No, okay. What's wrong, Ben? Something's wrong. What's wrong?
No.
Okay.
For example, I copy the note.
Okay. Okay, you brought that down, Go? Yes. Okay, so the next part now. The vector t multiply b, where t is 2 hours. What is the dimension of tb? Okay, so b. What's the dimension of b? What's the dimension of b?
Dimension.
Yeah. So what's kilometer measuring? What's length? And what's hour measure? Time. So this is length per time.
Yeah.
Okay. So b is length per time. What's t measuring? Time. So if you have length per time multiplied by time, you've just got length. So tb has the dimension of length. Okay, that's fine, right? So now the next thing I want you to do is to draw tb. So you have b, don't you? Where's your b gone?
Yeah.
There it is there. And the t is 2. So yeah, very good. There's tb now. Yeah, so just put a t in front, that's tb. Yeah, okay. You got that? Yeah? Yeah. B and tb. It's twice as long, yeah? Okay. Right, now I want you to use the vector triangle to add a and tb. Good, yeah. You could just write, yeah, so what you could just write here is a plus tb if you want.
I think we need that number.
Oh no, I don't need the number, no, not yet. Okay, is that okay, Ben? Yeah?
T equal to hour.
Yes.
So TB. I don't know how to draw TB.
Yeah, so B is 5 units
Yeah.
and TB will be 10 units. because it's 2 multiply 5.
Oh.
Yeah. You can think about it like this. This is 5 kilometers per hour. Then I multiply it by 2 hours. So they cancel, and I have 10 kilometers. So if this is 5 kilometers per hour, I can't really draw time. It's not easy. You can say that this is 10 kilometers. Yeah. Okay. Is that okay, Ben? The last one. What do you think this represents? So, in fact, the A and the B, they kind of have a meaning. There's kind of a story here. What do you think is happening? You know, you have the A, you have the B, and you have the T. What do you think the OR is?
Displacement.
Yeah. So could you give me the story? Like, could you describe what happened?
Okay.
So, at the very beginning you drew A,
Mm-hmm.
didn't you? Yeah, you drew A. What type of vector is A? Is it a speed? Is it a velocity? Is it a displacement? What exactly is A, do you think? Have a look here. 5 kilometers east, yeah. What do you think there? It's a place, isn't it? So it's a displacement. So what you're saying at the beginning is something is 5 kilometers east. Now B is 5 kilometers per hour north. So what type of vector is B?
Speed.
Velocity.
Mm-hmm.
Yes, velocity. So it's like you're saying, okay, there's something to the east and it's heading north. So then what do you think this TB means if T is 2 hours? Remember, TB is a length, it's a displacement.
Mm-hmm.
So what do you think it means? What has happened?
Something take 2 hours.
Yeah. So 2 hours have passed. So then finally A plus TB. So what that means is something started at A, then it travelled for 2 hours along B, and it finishes here. So in your picture, you have, here's something, it travels for 2 hours north, and it finishes here. So this is the end of the story.
Mm-hmm.
Yeah? Is okay?
Yeah.
Yeah?
Just is like ST.
Kind of like this, yeah. I kind of think of it more like this. OR equals A plus BT. That's a bit like final position equals starting position plus time multiplied by velocity. So it's like end equals start plus movement. Do you know what I mean? Like, this is where you finish, but this is where you started, and this is how you moved. So where you start plus how you move equals where you finish up at the end. It's kind of how I picture it. Is it okay? Are you sure? I don't know. Is it okay? You don't look happy. You look unhappy. Gail, is it okay? Yeah, Ben?
Okay.
Oh, are you sure? Should I believe you? Should I believe him? I don't know either. Alright, well, we'll continue. If you have a question, please ask me. Do you have a question?
No.
Okay, let's continue. So, here's another one. This one is, again, it's a little bit tricky. I think, yeah, so I have one more to do after this. I think we've got enough time for you to try it first. So let's try it again first. So, a man walks 5 steps north, then 5 steps west, then 1 step east, and then finally 1 step south. And this took 9 seconds. So he goes 5 north, 5 west, one east, one south. Okay. What was his average speed for his journey? So what's the formula for speed? What's the formula for speed? Distance over, what is it? You should have it in your notes, yeah? Distance, yeah, distance over time for speed. Distance over time, yeah. So what's the distance here? How many steps did he take? What's the distance?
7.
It's going to be, well, let's see, 5 plus 5 plus 1 plus 1, 12. And what's the time? 9. So it's 12 over 9 steps per second is the answer. Yeah. So can you calculate that, please? The first one. Yeah. What's 12 over 9? 1.3, is it?
Oh, you want point?
Please, yeah, why not? Yeah, 1.33, is it?
Yeah,
3, okay. Steps per second. Okay. Next we want to draw. So let me do this one now. We can draw this together. Right. Okay, let's make a nice big picture. Okay. I know. Ugly. It's my graph. Okay. Right, so let's see, where does he start? He has to go north. Okay, so we'll have him start here. And then he goes 1, 2, 3, 4, 5 north.
Yeah.
So that's the first one, north. Then he heads, then he heads 5 west. 1, 2, 3, 4, 5. Is that right? No. 1, 2, 3, 4, 5. That's the next vector. Okay. Then he heads 1 east. Yeah. And then lastly, 1 south. Now that's his velocities. Now we want his displacements. So I'll put that in green. First he's here.
Yeah.
Then he's here. Then he's here. Then he's here. And finally he's here. So can you see the difference? The blue ones are the velocity and the green ones are the displacements. Okay. Right, so that's B and C. So I'll give you a minute to draw this. Oh yes, yes. If I can draw it, you can draw it. Do you want me to keep the picture up or do you want the information? Information's better, yeah. That's a good ruler. Is that your GNIB card?
Yeah.
Nice. That's a very expensive ruler. That costs like €100. 300. It's expensive ruler. very good. Let's see. Ah, very nice. Very nice. Okay. Can I continue? So, what is the magnitude and direction of the final displacement vector? So remember in our picture, oh, that's terrible, sorry. You see this vector here? That was the final one. How big is it? Well, let me help you. I give you a little hint. So if you look at this vector, how big is this side? 1, 2, 3, 4 units. And this one here is 1, 2, 3, 4. So you actually know what this angle is. It's has to be 45. So that means it's northwest. But how big is it? Well, if this is 4 and this is 4, then this side, I tell you, if you have a 4 and a 4, then you have a 5.65. So the answer is 5.65 steps, and northwest is the direction. Yeah? Is that okay? That's the D. Lastly, E, what was his velocity? Now, this looks like the same as A, doesn't it? What answer did you get for A? You got 1.33. But you don't get 1.33 for E. What's the formula for velocity? Velocity, displacement over time. Yep. So that's 5.65 steps northwest over, what was the time? 9 seconds. So that's 5.65 over 9 steps per second northwest. You have that, Gail? What's that, please?
0.627.
So 628, we'll say then. Steps per second northwest. That's the velocity. I just wanted to compare that to the answer you got for speed. Speed was 1.33 steps per second. You see, it's actually quite different, isn't it? That's not the same. Okay, so if we can write this down, that was the answer for D, and that was the answer for E. Hungry, huh?
So in on physics, it's more preferred, like the answer more preferred the point.
In the exam, they prefer decimal point, yeah, in the exam.
So it's not like 1/3 or 2/3.
No, they like this in the exam.
Okay.
It's strange, but that's what they want. So. Yes, Ben?
velocity.
Yeah.
Velocity is oh oh okay
It's okay?
okay yeah
Okay, good. I'm happy you're good. Continue? Okay. So, consider vectors A and B. We say that vector addition is commutative. That is A plus B equals B plus A. But I think you knew this already. Yeah? Okay, so we're doing great. We're doing great. No trouble so far. We've got plenty of time for the next one to try. So maybe you could do these now and then you have no homework, which is good. Yeah, because I don't think it'll take you too long to do these. They're short. Oh, and I want bigger pictures, okay? So for the first, I want nice big vectors. American style, big American vectors, not small vectors. Extra large with a milkshake.